Hi, hello everyone. Alright, welcome to secondary school chemistry with Mr. Kelechi. And in this video, I'm going to be calculating our theoretical volume of acid to be used in our alternative B, forthcoming WASE 2026 quantitative analysis practical. And we know that the practical might, I am just speculating, right? No one has seen the question before, it's just a speculation. It might be a redox titration, redox equation. So how do we calculate this? We are told that our sample D, which is the acid, is an oxalic acid. Solution D is an oxalic acid, a hydrated one, dot 2H2O. And our solution E is an oxidizing agent, KMnO4. Now, how do we calculate the theoretical volume of acid to be used? We are told that while we are to prepare the acid and the base, the acid should contain 6.3 gram per dm cube and the KMnO4 should contain 3.1 gram per dm. So these are their mass numbers. Before we calculate the volume of the acid to be used, we have to note or we have to calculate their molar concentration. This is just their mass concentration. We have to calculate their molar concentration in order for us to calculate the theoretical volume of D, which is acid to be used. So first of all, molar concentration of D. Let's simply do that. We know that it is H2, this is 4, sorry, 4 oxalic acid, also written as this. This is structure for oxalic acid, right? Dot 2H2O. Now let's calculate its molar mass. Hydrogen, we know it is 1 times 2. Carbon is 12 times 2. Oxygen is 16 times 4 plus 2 into 1 times 2 plus 16. This obviously gives me 18. And this is 2 plus 24 plus 64, right? Now, 2 times 18 gives me 36. And if I sum all this, I will have 90. So 90 plus 36 gives me 126 gram per mole of D. So this is the molar mass of D. So how do we now calculate the molar concentration? We know that molar concentration is equal to mass concentration all over the molar mass, right? And what's the the mass concentration? 6.3 all over the molar mass, 126. And if we simply divide that, we are going to get 0.05 mole per dm cube of D. So this is the molar concentration of the D to be used. Now, what about the molar concentration of the E, which is the KMnO4? Let's simply calculate the molar mass first. KMnO4. We know potassium is 39 plus manganese is 55, right? That gives me 55, yes, 55 plus 16 times 4. And if we simply multiply all that, we get 158 gram per mole. So the molar concentration is the mass concentration, which is 3.1 all over the molar mass, 158. And if you divide that, we get 0.0196 mole per liter. All right, so these are the molar concentration of D and the molar concentration of E. Now let's simply calculate the volume of the acid to be used. Now, what formula should we use to calculate the volume of the acid to be used. We simply adopt our CAVA formula, but in this case, since it is not, the sample is not AB, we're going to use D and E. So CD, which is acid, times VD all over CE times VE equal to ND all over NE. Now, what is our CD? Concentration of the acid, 0.05. Volume of the acid, that is what we want to find, right? And number of the acid in a balanced equation. So since this is a redox equation, it has steps for the balancing. I've posted the video on how to balance for redox equation. So the ratio between both of them, if you check that video, you notice that the ratio is 5:2. This is 5, and our number of the KMnO4 is 2. So make sure you check that video to see how to get these ratios, right? Okay, so the concentration of the KMnO4, 0.0196, and the volume to be used, let's use 25 cm cube, a normal pipette size, right? Now, if we make VD the subject of the formula will look like this: CE times VE times ND all over CD times NE. I'll simply do that. Our CD is 0.05 and our NE is 2. Our CE, 0.0196 times our volume of the KMnO4, 25. Volume of the KMnO4, 25, right? Times our volume, our number of D, which is 5. So if we simply do that, the volume of this to be used, simply do that, multiply, divide all that, you get 24.5 cm cube. So this is the average volume of the acid to be used. Now, sometimes, or we might be told, instead of placing the solution D in the burette to get the volume of the solution D, we might be asked to pipette the volume, the acid, and then the KMnO4 becomes the solution in the burette. So either of them, 25 cm cube will be used for the acid, and after the titration, KMnO4 will be 24.5, or the other way around. So either of them, see, arrive at this. If the volume of the acid, the volume of one of them is 25 on the pipette, the other one will be 24.5. That is the ratio between both of them based on the concentration that we just calculated. If you enjoy watching this video, make sure you drop a comment, share to your friends, and see you in the next one.